So hello, I'm Dan Henebery, and welcome to Machine Learning for Early Warning and Open Source Investigations in Areas of Conflict. I'm Dan Henebery. I'm the Director of Analytics with Hala Systems, one of the companies that we'll be talking about now. To start, the way I'd like to work with this is we only have 45 minutes, so we'll be pretty prompt. I'm going to go through our panel, ask each one to say a bit about themselves and the organizations they represent. So with that in mind, I will first direct to Hadi.
Thanks, Dan. My name is Hadi, and I work as the Executive Director of Mnemonic, which works globally to help journalists and human rights defenders effectively use digital information of human rights violations and international crimes to support advocacy, justice, and accountability. And we've been working mostly in Syria, Yemen, and Sudan.
Excellent. Thank you, Hadi. And Adam, over to you.
Thank you. Hi, my name is Adam Harvey. I'm working with Hadi on a project called VFRAME. And VFRAME is a computer vision project that aims to bridge the gap between state-of-the-art technology and its application to human rights. This mostly means building lately object detection algorithms and applying them to conceptually the idea is to automate perceptual labor.
Excellent. Thank you, Adam. Next, I'd like to go to Welton.
Hi, thanks, Dan. Hi, everyone. I'm Welton Chang. I'm the Chief Technology Officer for Human Rights First. We're a 43-year-old nonprofit based in the US. And we work to empower Americans to fight for justice in our own communities and around the world. And just very much appreciative of my colleagues here today. And thanks for having me.
Thank you, Welton. Next, over to Bellamy.
Thanks, Dan. I'm Bellamy Hanoian, and this is my dog Raya that happens to be barking right now. I'm Director of Engineering at Hala Systems, and we are a company that builds technology to protect civilian lives in conflict and disaster affected areas. Our first major early warning product is Sentry, our early warning system for airstrikes in Syria, which works by linking our network of human observers and IoT devices to detect, predict, and warn the public about potential airstrikes 7 to 10 minutes before a strike happens. Since its inception, the system has reduced casualties 20 to 30%, saved hundreds of lives, and prevented thousands of injuries. And today we provide that life-saving information to over 2.3 million people.
Wonderful. Thank you, Bellamy. And then our final panelist, Rickard.
Thank you, Dan. My name is Rickard Nyman. I'm part of the AI and machine learning team at Hala Systems. I have a background studying mathematics at Imperial College London, followed by a PhD in computer science from University College London, where my research generally focused on machine learning, natural language processing, and forecasting. But the main kind of focus was in using machine learning techniques on unstructured text data to kind of extract behavioral indicators like sentiment, for example, and use it for predictive modeling. Prior to joining Hala, I also spent some time at the Bank of England in a financial stability directorate, exploring, again, how machine learning techniques could be used to add value to financial stability monitoring. And now at Hala, I primarily work on natural language processing problems, extracting information from open media data about areas of conflict to help inform our early warning systems, and more kind of generally working on AI and machine learning solutions.
Excellent. Thank you, Rickard. Wonderful. Well, thank you all. So to dive in, the first thing I would like to do is I would like to kind of go around the panel and hear a bit from each organization about how machine learning is being used. Machine learning is an umbrella term. It refers to a lot of things, and it can be used in many different ways. So with that in mind, I would like to first go to Hadi and learn a little bit about how you've been using machine learning.
Absolutely. Thank you, Dan. So I'm just going to go through very quickly. I hope that you're going to be able to see my screen. So with Mnemonic, we create digital archives of international crimes. And we've been doing this work in Syria, Yemen, and Sudan. In Syria, we have been doing this work since 2011. And we have over 3 million records that we have archived documenting human rights violations and war crimes in Syria. And here you will be seeing, I hope if it comes up, the workflow of how we do the work. With this workflow, we start from first collecting the media records that are published by journalists and humanitarian groups and media groups, either from online or directly from those groups. And we preserve and centralize everything in one database and in different servers for security issues. And then we do the processing when it comes to extracting the metadata. This is where also machine learning comes in our part, because we are a very small team of researchers. So the Syria team that is working with us, we are around 6 researchers right now. And we are dealing with a huge scale amount of materials, so over 3 million records. Those media records that we are working on, they, after verification analysis, we're able to use it to support legal case building or to support advocacy research. That's why it's really important and high priority for us to be able to find the relevant media for those cases. And this is where we, when we process the materials with machine learning in order to identify certain objects within the media, and that's going to be part of the metadata, then researchers are able to prioritize those videos, see, for example, the videos that are more relevant for them, that shows certain munitions, for example, or certain objects that they are looking at. And that help us to do the verification on this media and then to do the analysis on it in order to feed it into legal case building or advocacy research. So I'm gonna stop it here and ask my colleague Adam to add any other details if time allows, Dan.
Yes, please.
Yeah, thank you, Hadi, for initiating and describing the methodology. I'll pick up with trying to show the way that we collaboratively use machine learning, of which computer vision and object detection is a subset. So I will attempt to screen share. Let's see. Well, while I'm doing this, the way that we work is generally to do object detection, you'll need a lot of training samples. And one of the major problems with monitoring videos with OSINT videos is you end up with not many real videos of the thing that you're looking for, in the neighborhood of only 1% to 2% of what's needed. This is a major problem, to the point where you can't really do AI or computer vision on most of the things that you want to. So let's see if this works. The way that we go about doing this is to kind of unlock the potential of computer vision by using synthetic data. Synthetic data can come in 2 forms that we use. Okay, it's not going to be able to share, but on the website, it's okay, you can go there. We 3D render it, and this provides a decent level of data. And then we enrich the 3D rendered data with 3D printed data. So we develop a replica munition, actually take this out into an environment that looks like the scenes where we're detecting, and then use these to, thank you, enrich the 3D rendered data. And this is unlocking a big potential of computer vision, because virtually it allows you to detect anything. This before was the stopgap between developing what's called a model zoo, or a visual vocabulary of the items, in particular for Hadi in the Syrian archive, would be cluster munitions. And the way this works holistically is a process of iterative reduction, as Hadi mentioned, surfacing the most important videos to the researchers first and deprioritizing the ones that do not contain the object. We can get approximately 70% detection accuracy using this method. A lot of the objects, as you can see here, this is from a 2019 prototype, are damaged, completely covered in dust. Often they're rusted or broken apart, and that accounts for a lot of the remaining 30% that are difficult to detect. And it's with about 5 to 10% false positive rate. So overall, this provides a huge benefit to the researchers when you're looking at hundreds of thousands of videos or millions of videos, and it runs entirely offline. So the videos never need to leave the confines of the studio and the research team. I'll leave it there. I don't want to take up too much time, but I'm happy to field more questions about it.
Excellent. No, thank you, Adam. Very good. So next, I'd like to go over and ask Welton, a similar question to you. In what ways does Human Right First see machine learning as useful for ensuring justice and accountability related to police use of force?
Thanks, Dan. And really cool computer vision tech there, Adam and Hadi. That's, we're working on some computer vision projects as well. And so HRF has an innovation lab, pretty new part of the organization. And what we're doing with the lab is it's our hub for discovering, developing, and delivering solutions, tech solutions to pressing human rights issues. One of the projects that we have ongoing is a project called Blue Witness, which is a system for detecting and then visualizing police use of force incidents, specifically in the US. But what our hope is that by open sourcing the system, others will be able to use it in their geographic areas of concern. As many of you know, this past summer was a pretty intense period across the US as far as exercising of First Amendment rights. And the responses from law enforcement across the country have been cataloged by citizen journalists, by actual journalists, by just bystanders. And all of that data is essentially out there in the public domain. And one of the ideas that we had internally was, how do we aggregate this data? How do we collect it so that folks can sift through it? So specifically journalists, but also just your regular concerned citizen can get a better understanding of what exactly is happening across the US in terms of use of force. So I'm gonna quickly share my screen here to show a prototype of our system. So how the system works is we have a multi-stage machine learning method, k-nearest neighbors, Google BERT, that pulls in data from Twitter and Reddit that then gets passed through, and essentially we bring the data in, collect it, bring it in, and then an administrator will go through and ensure that this is an actual report of a police use of force incidents, and that will be sent to the back end, update the database, and then displayed on the front end that you see here. The front end allows you to kind of dive into specific incidents, learn more about what's going on. You can see the information if that's actually, can I click it from behind here? There we go. Find out more information there about what happened. And I think the key to how what we're thinking here is that once the system is finalized, anyone anywhere can use the code base to set this up for their specific area of interest. So we heard this as a significant need from activists, protesters from Belarus to Nigeria around the NSARS protests to Hong Kong, and Myanmar and many other places where law enforcement and state security services are using force, and those force incidents are uploaded to social media. So this would be a way for those organizations to be able to take all that data and make better sense out of it. So here you can see we have some of the latest incidents grouped by the type of use of force. You can dive in and look at the details of the incidents themselves and look at some graphs about the data. And the key kind of audience for our system is journalists, but really anyone who has an interest in what's going on can extract some insights out of it. And happy to answer questions if there's time, but I'm going to turn it back over to Dan because we've got a lot of other stuff to get through. So thank you.
Excellent. No, thank you, Welton. I'll just point out that these are obviously different use cases, but I actually happen to have the opportunity to sit in the room with the group that was developing some of the synthetic data that Adam referred to, and I know that tear gas canisters is one of the things that's in their collection. So next, I'd like to pass it over to my colleague Rickard and ask him to sort of explain how Hala uses machine learning to support airstrike early warning.
Thank you, Dan. There are several areas where we use machine learning, but I suppose there are two in particular. One is in information gathering and extraction. So both from remote sensing devices and from publicly available online media data, such as social media and news. And the other is in prediction for our early warning system. What's critical to the effectiveness of our early warning system is information gathering with high precision and high recall. So for anyone not familiar with that terminology, precision is a measure of how accurately a system has provided relevant information, and recall is how much of all available relevant information the system has provided. So the early warning system then can use this information on what has happened in the past, in addition to other inputs to track aircraft, analyze attack patterns, and send warnings to civilians of imminent attack. We have developed a platform that constantly ingests posts from open media, flags those that mention an airstrike in Syria, and then correlates those reported airstrikes with observed aircraft activity. And this helps train the machine learning prediction algorithm so that the system can provide more accurate warnings of future airstrikes. So originally, this process was performed by human experts who spent a significant amount of time searching online media for relevant information about airstrikes. However, as you can imagine, this is a very time-consuming process, and the volume of data is very large, so that the monitors may not be able to cover everything. Not to mention that it tends to be a very emotionally draining activity for people to carry out. So to improve the process and increase the scalability, we developed and deployed a machine learning system that ingests this data from platforms like Facebook, Twitter, Telegram, and others, and detects and aggregates evidence of violence. And in the case of Syria, this was specifically evidence of airstrikes. But beyond this, we've also expanded to cover different types of incidents in different languages by making use of more kind of recent advances in NLP, such as, for example, multilingual deep learning methods. And for anyone who's interested in more details, so this model, we presented it in a paper at NeurIPS in 2019 that can be found on the NIPS conference website. But in summary, the system has to decide what information is relevant. So if a post mentions an airstrike, which we trained a supervised machine learning classifier to do, then extract the features of the events that we care about, such as the time and location, before finally grouping together that evidence of the same events using various clustering techniques. Crucially, by grouping together evidence from multiple disparate sources, we can get a more accurate picture of what actually happened in the area historically. And part of this task also involves trying to model which sources are the most reliable, which can be a challenge by itself. And with this information, we can then calibrate the warning system by correlating the information with other data inputs. So that's kind of the main area where we use it. But in addition to this, we also extract or have developed machine learning models to detect various events from remote sensors, and we're also working on methods to combining this data with other sources and third-party data, etc., to improve on the effectiveness of the system as a whole. So that's hopefully that gives a kind of broad summary of how we use machine learning for early warnings.
That's excellent. Thank you, Rickard. So next, we've got a few more questions that are going to deep dive into this. But I think the first one, really from K-Don in the chat, this is very relevant to the first question I was going to ask. I'll direct this at my colleague Bellamy, but feel free everyone else to chime in as well. That it can obviously be very difficult, especially for organizations that don't have much experience using these tools, to start to find ways to actually utilize them. We've got a lot of smart people on this call, and a lot of that knowledge was hard won, and maybe not every organization has someone like you or is prepared to make that investment. So Bellamy, given that it can be difficult to bridge this gap, how has Hala tried to to work with partners to bridge the gap between the expertise of the data scientist and the real world where this stuff actually needs to be used?
Yeah, that's a great question. I think the first thing that comes to mind, especially because we're in a conference with practitioners, is about operationalizing the work that we're doing with AI and ML into our production software systems. So as far as the people who actually need to use this information, we typically have two buckets of users. We have the people who need real-time alerts and the people who don't. For those that do, our production systems need to be fast, they need to be reliable, but for those that don't, our models can take a little bit more time for complex processing. So taking the user needs into account while you're developing those production systems, I think, is a critical step one. And I mean, we've had a lot of challenges operationalizing our AI and ML. But for example, our software infrastructure follows event streaming and serverless architecture patterns. And this is sometimes in contrast with the ML models and the analytics pipelines that we've developed. But we have developed a few strategies to make this a little bit more cohesive. So we try to apply best practices of software production systems to our analytic systems, and I think this is critical. So for example, we have CI/CD pipelines on our analytics scripts to deploy via Kubernetes, as well as things like error reporting and monitoring capabilities. And this is just the same as we do for our production level user interfaces and things like that. This allows the analytics teams to control the logic, but the DevOps and software teams can protect and maintain the reliability of the system overall. We also have a data lake architecture on AWS, which we are continuously working to develop, and its role is to make the data more accessible to the data teams. We've adjusted some of our processes for the event streaming to be asynchronous because we want the systems that need the data to get it as soon as possible. So for example, an ETL script won't block our early warning system and things like that. We have developed our pipeline to be a little bit flexible in that way based on the event streaming architecture. So those are examples of how we have kind of like production, how we have built our systems for production readiness. And for advice, I'd say, first, you should have well-defined patterns, but plan to adjust them after much consideration of the benefits to the users and the cost of maintenance. So that goes back to our, we're serverless, but we have a heavy use of AWS Lambda, but we make adjustments to this pattern if we need to deploy new services via Kubernetes and SageMaker and things like that. So we make adjustments based on the needs, but we try to stick to our original patterns. Second, I'd say that reducing concerns, which can also be restated as modularize your system. So if there's something that the ML model is doing that can be abstracted into the larger system, I'd say do it. Like basic feature extraction and data restructuring are good candidates for this, as the results can be used by many systems in the production system. And it can also reduce the maintenance overhead for the dev teams. And then third, and this goes back to more of the like on a product level, I would say you need to talk early and talk often with your users, with your dev teams, with your analytics teams, because it's really critical that you're developing things together, and something that the users can use, something that the dev teams can deploy, and something that the analytics teams feel confident in. And this goes from like requirements to how it's going to be fit into the system, to feasibility, to scale needs, and all of those things. So I know I kind of jumped around from product to production systems as practitioners, but I hope that answered some of that question.
Thank you, Bellamy. And I'd like to open up to the other panelists. Anything to add?
I'll add that, yes, the technology is complex. Making it uncomplex is a multi-tiered process. Everyone will have their own deployment strategies and comfort level with different kinds of technology. Whether you want to run everything offline in your studio or to process things in the cloud and deploy it in a scalable infrastructure with Amazon Web Services, everyone is going to have a different approach here. So with VFRAME, one of the approaches is to publish as much as possible open source and release all of the detection models for free. That way, because everyone is using a different infrastructure, you can kind of pick and choose which pieces from the project that I'm working on might fit into your project. And I think from my own experience, it's quite difficult to decide on a data schema or data protocol, even within your own organization, let alone impose one on other people. So I've actually taken a step away from that and just trying to provide some of the core capabilities in object detection that can be integrated into your own custom workflow.
Thank you, Adam. I might also add that I think you touched on this, Adam, but that if there is, it really kind of depends on the comfort level of the organization itself. A lot of times, we're talking here about machine learning, which is in terms of data actually relatively sophisticated. But if an organization so far has not been operating with this historically, it may just even be more impactful to actually just start using data in a day-to-day basis, and then that can grow into using these more sophisticated tools. Last call before I move on from this question. Excellent. To the next one. I'll direct this first at Hadi. How has the Syrian archive sort of combined the output of these machine learning models with the efforts of human investigators?
Thanks, Dan. So part of the work of the Syrian archive is to create thematic collections of the media. Like, for example, we would create a collection about media related to all attacks against hospitals or attacks using certain weapons, for example, using missiles that deliver chemical weapons or using cluster munitions. And with this, researchers accumulate lots of experience in identifying those munitions within the media itself. Now, the issue that we are facing, the challenge, is that the media is in a huge scale, and it's really hard for the researchers to find those specific objects within the large data set. And here where the VFRAME software comes to identify those objects automatically, but that happens through the researchers first. So what VFRAME created is an annotation platform for researchers to identify the objects that they are seeing, the ones that are really important for us, the one that we also know from experience working with lawyers, working with the police, working with war crimes units, they need in order to verify certain incidents. And that feeds into VFRAME and the training that it does. And I'm going to ask my colleague Adam to talk more technically about this.
Exactly. So first, it begins with the researchers identifying what's important, collecting a handful of videos, as many as they can. Then we kind of chop these up into keyframes and put them into an annotation pipeline. Those annotations then serve as the benchmark or the ground truth. And that ground truth is used to evaluate the synthetic data. Of course, you're only able to see as far as the data that you have. So if you want to develop an object detection model or any form of ML, you need a lot of field experience, knowledge. That knowledge comes from the researchers who have watched thousands of videos and can understand that, communicate to me that the object appears broken, split, rusted, on its own, split open. Maybe there's a new version and a slightly older version. Maybe one of those versions is more important. So in reality, the simple process of detecting one kind of semantic object becomes split into many different submodels. And then we work together to build the pipeline that then will train on the 3D rendered synthetic data and to analyze the larger archive of videos and then find ones that the researcher has missed in the existing collection and then analyze at a much larger scale into hundreds of thousands of videos with that computer vision model.
Excellent. Thank you, Adam. Yeah, I will echo that, that at Hala we have found that having the experience of people on the ground, people who have intimate experience with these things is absolutely invaluable in the creation of reliable training sets. Thank you. I will also, just as an aside here, to the audience, I am monitoring the chats. If you have any questions you want me to address, please, by all means, put them there and I will take notice. Next, I'll go to Rickard. One of the challenges we have is, of course, the curse of small data. We hear a lot about big data, but that isn't really available in a lot of the places we've been talking about. Can you speak a bit to how we overcome these challenges?
Certainly. I mean, as you point out, in conflict areas, it's often difficult to get a lot of data, and the data that we can gather are often subject to high levels of noise. And I think I'd like to just make a number of different points here. First, I think it'll be helpful to just remind ourselves of a very fundamental kind of data modeling property, the bias variance trade-off. For those of you who aren't familiar with this, in simple terms, the bias variance trade-off is essentially a mathematical statement about two sources of errors that a model has when it's applied to new future data. The bias errors are those errors coming from incorrect assumptions of your model or biased assumptions, such as, for example, assuming that there is a linear relationship between the input data and the outcome, when the relationship is in fact nonlinear, so for example, quadratic. In this case, the model would underfit the training data. So that's one source of errors. The variance errors are those coming from a model's sensitivity to small variations in the training set. So if a model is very sensitive to the specific set of training data that it uses for calibration, it often ends up fitting the noise in the training data and not the true signal, which is going to result in overfitting the training data. So these two different sources of errors are essentially competing in that if you reduce one kind of error, you often increase the other type. And since the data that we work with coming from conflict zones are often very small in volume and it can be highly noisy, it's therefore absolutely imperative to avoid the variance type errors. which are much more likely to creep into your model when data are small and potentially noisy. So in other words, it's key to always prefer simple models to more complex ones. So for example, prefer a linear regression to nonlinear regression, prefer linear support vector machines to an SVM with a Gaussian kernel, for example, etc. Right? So you should lean towards simplicity. The second thing to keep in mind is to incorporate as much expert judgment as possible into your data modeling pipeline. So even if this might appear to make your model fit the training data slightly worse, it's still likely that the introduction of such a bias will in fact help your model generalize better. And again, so we prefer model bias over variance in this instance. Here, a trivial example of expert judgment might be, what's the physical constraints of how quickly something can move, for example. So that'd be an obvious case of this. Third, when you don't have a lot of real-world data to use, it can be a good idea to use simulations and agent-based modeling techniques to try and incorporate that kind of expert judgment and generate synthetic data, which can be used to help test models, potentially simplify them, as well as helping with calibration of them. Finally, which is the last point, we try to make as much use as possible of different alternative data sources. So linking them together to try to form a more kind of precise view of our data. And so the most simple approach here could be to just average data from multiple sources and sensors, and therefore reduce the noise in your final estimates, which is obviously something that, for example, the central limit theorem from mathematics would tell us is a sensible thing to do. So these are the sort of things that we try to keep in mind when working with smaller data sets.
Excellent, thank you, Rickard. And just to point out that when Rickard says expert input, he is again referring to that of the individuals that are most intimately familiar with the conflict. And actually, because it dovetails fairly well with that, I think I'd like to address a question in the chat from Edward Knight. What about overfitting to a Syrian context? Obviously we've at least Hala and Syrian Archive are very focused on Syria. How well does this transfer out to different areas of conflict? Either Hadi or Rickard, or Bellamy, sorry.
Maybe Adam, you can speak about the experience in Yemen.
It's very particular and won't always transfer. As Rickard said, bias is an issue. It can also be something that you design with. So for example, in Yemen, we're looking for a very small munition, and that means the model needs to be retrained to look for small objects. Whereas in Syria, we're looking for some rather large objects, like a tail fin of a cargo munition. And the other thing to consider is the resolution of the cameras that are being used to document it. Higher resolution cameras like GoPro capture more detail and texture. And in videos taken now from 10 years ago, 5 years ago, they have almost no texture. These were captured with much lower resolution phones. And so they exhibit different artifacts in the image. And from where I stand, it's an entirely different model. And the degradation techniques that are used on synthetic data need to be very particular and well thought out for the domain it's being applied in.
If I could just add from my perspective, I completely agree with that. And I think we find that it's often important to retune models to specific context. Obviously, there are techniques out there that you can use to help you with that, such as transfer learning techniques, for example, which might make it a little bit quicker to adapt to new contexts and new data sets. And I think just to touch on what I believe is the second question by Laura, we do also try and explore different language models. So there are new techniques out there now for applying the same kind of model to the same to different language data. So there are some interesting bidirectional LSTM models, for example, which have been trained to give good kind of representations for text in different languages, and that has definitely shown to be quite helpful. But again, we are most often ending up having to try and recalibrate data to new contexts.
Excellent. Thank you, Rickard. Anyone else on this question?
If I could jump in again, sorry to feel like I'm saying too much, but the approach that seems to be becoming more common is called ensembling. So instead of relying on one single model, you ensemble multiple models to account for the variances. For example, if a video is shot on a high resolution DSLR, it's going to contain so much texture that it won't be detected by a network trained on low resolution. But the solution is simply to ensemble your models, train one for every kind of specific cluster of sensor technology, and then to chain them all together. So a model is an ensemble of smaller models, is the best way to think of it. It always contains more submodels and sub-algorithms as the one that Rickard was describing.
Thank you, Adam.
Hey, Dan, do you mind if I tackle Laura's question in the chat?
Please do.
So Laura's question is working in areas where there's multiple languages and dialects, and the difficulties in doing machine learning on different types of content. And so we have a separate program called Digital Shield, which we use to detect online threats, hate speech, primarily against human rights defenders. And we're working in a couple of different languages there. There's a couple of different solutions to this. I would say, this is a point that Rickard made about having experts involved. They're absolutely essential to ensuring that your data is curated properly, that your data sets are as accurate as possible. There's lots and lots of different ways of expressing threats in different languages. Some of them are very context specific. For example, in the Philippines, being red tagged or being accused of being communist is basically a death threat. And that's not something that you would see, from a language context perspective, be the case in somewhere like the US, for example. So always keeping in mind that there are folks who know the context, understand what's going on, and can help you navigate that specific area in that way. I think more lightweight methods of getting around this is basically translating everything into English and then using that as the basis, or I think both Rickard and Adam mentioned this. So there's ensembling, there's new methods that do multiple languages, different models that are capable of doing things other than English, and many different languages. And BERT is one of those capabilities. You may prefer to build on top of that rather than using some jankier method of like translating everything into English and then using that as your data. So yeah.
Well, Tabitha, I really wish we had time to answer that question. Please reach out if you want to know more. In the last moments here, I'd like to go one at a time through all of the presenters, and in one sentence, what should a data nascent organization do if they want to get into this? Bellamy, go.
Can I pass and come back to me?
Of course. Rickard, go.
That's a great question. I mean, try to, just going to raise again, work with experts in whatever you're trying to modeling. I think that is the key thing to do.
Welton, over to you.
Okay, I'm ready.
Go back.
Okay, I'm ready. I'm going back with the talk early and talk often, similar to Rickard's.
Welton.
Yeah, there are lots of partner orgs you can work with. I think that's the really nice thing about folks in this space is that everyone's very collaborative and nice. So yeah, try that.
And Hadi?
I think it's really important that you don't reinvent the wheel, and there's a lot that has been done already, lots of open source code that you can also use and see if it fits or see how you can adapt to.
Excellent. Thank you, Hadi. And Adam, final word.
Collect it all and analyze it later. The more data you can get, the more it can inform your models.
Wonderful. Thank you all. I really appreciate having all of you here. Thank you so much. Take care, everyone.